I'm going to talk a little bit more philosophical about software engineering. And in particular, here, we're going to look at the sort of lifetime of a software project and how it evolves. And we're going to talk about how newer technologies allow for complexity to be managed. So when we talk about memory safe languages, in particular Rust, that are going to address the complexities of maintenance, this is what it means. When you first start a project, it looks like this, it feels like this, where you are early on in the project, you have a very small team, usually one or two people, and they are able to manage everything on their own. So you have parsing, you have networking, you have persistence, you have configuration, and all of these have technical complexities to them that you have a very good handle on. Networking deals with buffers and ownerships. There's threading models in configuration, static versus dynamic configuration. Parsing, are we doing zero copy? What are the assumptions that we're making about the protocol? Even in persistence, there's things like optimistic replication that are complex issues that you have a really good handle on because you're early on in the project and your scope is very manageable. So what happens as the project continues on during its lifetime? So I'm going to suggest that it starts to look something more like this. All of those individual components, the parts of your software that have complexity, have maybe some degree of autonomy, components, whatever they are, start to drift apart from each other. And the details about what they're doing inside start to become less clear, less fuzzy. And this happens for a variety of reasons. This drift, some of it's time. You might have attrition. There's interest. What are we now interested in from a technology point of view, new technologies that come in, and just priorities. This is a going to happen. And the thing is that these red lines, there's interaction between these components that matter. The ownership, the threading models, the assumptions that we're making still matter, and they have a play in the proper execution of this. And when we have a new feature that comes into play, it is going to interact with all of these systems in some way. And you need to know these internal details in order for this new capability to not cause problems. So the typical mature thing that we want to do in a software application or a software project is to have your documentation, to be able to put all of the technical details about what you're doing inside of these components into some sort of narrative prose documentation that allow the developer, new developers, old developers, whatever, to reference this documentation so that when there is a new feature that they're needing to implement, they can, in theory, it's not even just in theory. Like it is. If the documentation is right, you should be able to have all of the technical details that you need to know in that documentation. But this is kind of problematic in itself, in the sense that as these components change, there's now even more arrows that are in play. You still have the red arrows, the interaction between the components that are critical for proper execution. And if you make changes, you have to change it here. You have to change it in the documentation. There is a technical process that you need to put into place to make sure that this documentation is correct. But then there's also this yellow line that says, is it complete? How do we know it's complete? And how how do we know that we have read enough of the documentation to know that a feature is going to have an interaction with a component that is going to be critical or not? So we add on top of this different processes. We have DO-178, CMMI, various agile, lean, safe mechanisms that try to put into place discipline on top of all of this to make sure that we have everything complete, so that sort of if something does go wrong, it is because one of these process mechanisms was not followed. The documentation didn't exist. If we do a root cause analysis, we can say, oh, we did not have the proper documentation. They did not refer to it. It was incomplete, whatever that is. And I don't want to say that process is a bad thing, or that these project management mechanisms or standards are a bad thing. It is that there are mechanisms inside of software, inside of languages, that allow for this and this, the documentation, to be a more integrated part of the software development experience altogether. So that these interactions, these red lines between software components, are the correct behavior is enforced by technology. So if you're to look at the the words that I used inside of here, these things like zero copy, the byte ordering, the buffers, the ownership, the threading, all lifetimes, all of these things are technological problems that languages like Rust have attempted and do overcome, so that the interaction of ownership, the interaction of lifetimes, the interaction of threading has a technically enforceable mechanism that is not documentation, it's not process, it's not due diligence. It is part of the software itself. Again, it's not to say that you can eschew documentation or process, but they mean a different thing when you look at this sort of drift, because these interactions still take place and this drift is still going to happen. But if you can implement a new feature and have that new feature not have to worry about the issue of lifetimes and ownership and threading and assumptions that are made with like that, you can implement that knowing that the technology is going to protect you against most of the interaction issues that are going to cause unforeseen problems. So this is the groundwork that I'm trying to lay from the point of view of the sort of business project management problem that we're trying to solve with technology, and to explain how a memory safe technologies are going to address this, because I say that they will. Now, I'm going to talk in future videos and describe how an earlier generation language like C++ exhibits these interaction problems, the red lines, and how a newer technology, newer generation language like Rust, if you make these new features to add zero copy or other things in play, that the language itself will protect you from these interactions that usually cause your they require a cognitive load that you can then dedicate to solving the problem rather than dealing with the complexities of interaction and the drift over time. So this is the baseline. Hopefully this is going to be helpful, and follow along with the technology videos as we play, and we'll come forward and back to this. I'm trying to use this to communicate what I've learned over almost 30 years of professional software development and having been introduced to new technologies. So stay tuned. Thanks for watching, and hopefully this is helpful.